If there are A possible outcomes for one event and B possible outcome for another event, then there are A cross B or multiplication of their outcomes. That is the total. That will be the total possible outcomes if they are put together. For example, we take two dice. When we put them together, like plural is dice and singular is die. So when two dice they are rolled together, D1 and D2, we know that for each of them there are six different events, like we can get either 1, 2, 3, 4, 5 or 6 from each of them. So if we roll them together, we can have 36 possible different possible outcomes. So like for example, we can have 1 from one die and 6 from another, and in this way we can have 6 into 6, 36 different combinations. Here we can elaborate this rolling of two dice together in this example where we are summing up their outcomes. So from first die, blue, we get 1, and from the second die we get 1. When we put them together and when we sum them, we get a 2. Let's roll two dice together, and in order to distinguish between all 36 outcomes, we sum their outcomes. So for example, from die 1, which is represented as blue here, and die 2, which is represented as green, if we roll them together, we get 1 on both sides, we will get a 2. If we get a 2 from this first die and 1 from the second one, we get a 3, and so on. So total we get 36 possible outcomes. The biggest sum is 12, where we can have 6 on both of them, and smallest one is 2, where we can have 1s on both of them, and we can get more 7s here in the middle. So with these 36 events, we can draw different probability distributions. So two events A and B, they are said to be mutually exclusive or mut x if the occurrence of one event excludes the possibility of the other event. Example will be what is the probability of getting a head and a tail both in just one event. So either you can get a head or you can get a tail. You cannot get both of them together. So same way, survival or death of an organism is some experimental unit in which you are applying some treatments. Say for example, you are applying the treatments on rats. In this example, the rats are your experimental units. So whether they survive or they die, so we cannot have for each individual, we cannot have both the things possible. If it survives, it might have not died. So these are two, death and life, they are mutually exclusive events. So if two events A and B are mutually exclusive, then the probability that either of the event is occurring is P of either A or B, which will be equal to P of A plus P of B. So either of them, we can simply add their probabilities. And an event and its complement are mutually exclusive. So complement is probability of something not happening. So if probability of occurring A is PA, then its complement is probability of not seeing this event A. So we believe that P of A plus P of A complement is equal to 1. Here in this example, again we can use the previous example, rolling these two dices together. What is the probability of getting a 4? So we solve that and we see that there are 3 possible ways in which we can get 4. So probability is 3 out of 36, which is 1 out of 12. Now this is something which is happening. So what is the probability of something which is not happening? So what is the probability of not getting 4? Here in this example, so we take these 4 out and remaining there are 33 different outcomes. So probability of not seeing a 4 or complement of 4 is actually 33 out of 36. So when we add both of them together, it adds up to 1. So A and B are mutually exclusive events associated with an experiment. Then A and B, they must satisfy following properties. Let's see the properties of these mutually exclusive events. We see that their probabilities, they range from 0 to 1 for both of them, for A as well as for B. And the probability of either A or B is simply the sum of their individual probabilities and their complements if we put in the equation. So probability of an event and its complement equal to 1, and this is true for both of them. So events are A and two events A or B are said to be mutually exclusive, mutex, if the occurrence of one excludes the possibility of the occurrence of the other.